Good day everyone. In this video, I am going to solve a problem in application of maximum and minimum and some problems in derivative. Our first problem is all about the application of maximum and minimum. A rectangular lot is to be fenced along a highway. If the fence of the highway costs $M per yard, on the other sides $N per yard, find the area of the largest lot that can be fenced off for $K. Our first step to do is to draw a diagram. It is said that along a highway is a rectangular lot that need to be fenced. So, here is our rectangular lot with a fence along the highway, and we are going to label the width of the rectangular lot by x and the length of the rectangular lot by y. After drawing the diagram and labeling the width and length of the rectangular lot, we need to find the total cost. So the total cost will be K is equals to mx plus n quantity of 2y plus x. We get this equation which is K is equals to mx plus 2 quantity of 2y plus x by manipulating different variables according to the problem. In the problem, the $M per yard is along the highway. That's mx, m, this is the m, along the highway, mx. Then our $N per yard is on the other sides, which is equals to 2y or 2 lengths and the one width or the x, or 2ny plus x. Then our k will be equals to mx plus 2ny plus nx. 2ny by multiplying n by 2y, so it will going to be 2ny. Then the n times x is equals to positive nx. Then after getting this equation, we are going to move left side the mx plus nx. So the mx plus nx will be equal to negative, or k minus quantity of m plus n x is equals to 2ny. In this problem, we are going to find the value of letter y. So our y will be k all over 2n minus m plus n all over 2n x. We get this value of y by dividing both sides by 2n, then cancel the 2n here, then we will have y, then k all over 2n, then minus m plus minus quantity of m plus n x all over 2n. After finding the value of y, we are going to solve now the value of our area. So this is the value of our y, which is equivalent to k all over 2n minus m plus n all over 2nx. While ago, I've said that we let w or width is equals to x and let the length be equal to y. Then our area is will going to be a is equals to xy, or x times y. After that, we are going to substitute the value of y in our problem. A is equals to n quantity of k all over 2n minus m plus 2n plus n all over 2n x. Then substitute or multiply x by k all over 2n. Then it will going to be k all over 2n x minus multiply x by m plus n all over 2n x. Then it will going to be m plus n all over 2n x squared. After that, after finding the value of y, the value of area, we are going to solve or find the value of x. We are going to solve this by finding the derivatives of our area. So the derivatives of our area with respect to x is equals to k all over 2n minus m plus n all over n x is equals to 0. Then we are going to our problem will going to be k all over 2n is equals to m plus n all over n x. Then the value of our x will going to be x is equals to k all over 2 quantity of m plus n. After finding the value of x, we are now going to substitute the value of x in our total cost, which is equivalent to y is equals to k all over 2n minus m plus n all over 2n, and substitute the value of x which is equal to k all over 2 quantity of m plus n. Then after that, after solving the problem, we are having the value of y is equals to k all over 4n. Now we solve the value of both x and y. Then we are going to substitute the value of x and y in our area. Then our area will going to be k all over 2 quantity of m plus n times k all over 4n. So the area of the largest lot that can be fenced off for k dollars is equals to k squared all over 8n quantity of m plus n squared yard. So this is our answer. Area is equals to k squared all over 8n quantity of m plus n squared yard. Now, in this problem, we have now a different problem, which is a derivative. The first step that I always do to solve this easily is to understand what's the technique that need to be used, or what's the rule that need to be used. In this problem, we have implicit function and derivatives of trigonometric function. So we are going first to solve the left side, which is the derivative of x y squared. So the derivative of x y squared is equals to x, the derivative of y squared, which is equals to 2y prime plus y squared times the derivative of x, which is equal to 1. Then we are going to